All right, quiet please. All right, hey, we'll go over this real quickly. Any questions on the exponent review worksheet? That the answers were on the back. That the instructions were over there. Some of you, Tony and I got them right here, but not all of you. Right. Time out. Time out. All right. Any specific questions? All right. Basket coming around shortly to collect that. Hey, adult speech right now. Hey, no joking. Today's the first day. You don't know any of this. None of you know any of this. None of you know any of this. This is pretty easy what I'm going to teach you. But this is it. You know, we finally reached the first day for everyone in the class. Maybe last class, a couple people knew how to do this stuff. But that's it. It's done. We now have no one in the class who knows how to do this stuff. If the behavior, 100%, okay? If the behavior stays for some of you as it currently is, we can put the F in the grade book right now. That's where this will go, okay? Now's the time that we turn our brains on, and, you know, maybe now we need to start thinking about better seating. If you're seated next to someone who you know you have no chance of paying attention, I will give you a new seat, right? I will force that on you. Typically for upper school, I don't have seating charts, except for the kids that I need to have seating specifically, that I either have access to them to help them, or they've demonstrated they can't sit next to this person. But I'm okay with you sit not on the floor. You sit where you want to sit. I don't have a problem with that. You're in high school now. Not all teachers do this, but some do. I'm one of those. Please, when you hear me make these speech, know that it comes from the position of I've taught this for many years. This is where it goes bad for some of you this day, right? Maybe it's already gone bad for some of you. But this is where it goes wrong, is that you're walking in this class thinking, well, I've done so good so far. I haven't really paid much attention, and then that continues today, and then you get lost, and it doesn't get easier. You know, it doesn't get that much harder either, but it doesn't get any easier. Please pay attention and take great notes. All right, there's end of speech. All right, we are doing something today that every single Algebra 1 student learns. We're doing something that I don't know what it is about this thing, but you will have parents or older sisters and brothers, they will see that you're doing this, and they will rip the book from your thing, and they'll want to do it themselves. I don't know why. It's just something about this particular one. But it's something that all kids remember, and maybe it's because it's easy. It's the first hard thing they do in algebra that they're successful at. It's also the one thing that you're going to do between now and your last math course, right? You're going to do this thing that we're about to do. And it becomes a comfortable thing like adding, subtracting, multiplying, dividing. But it is definitely new for you. You haven't done this. It is not, I don't know, of all the things we do, wrapping your head around it is not hard to do at all. But it is a technique. And it is something new. So, chapter test. So I think I probably won't do 4-7. It's been a while since I've done a regular class. I've only been doing honors algebra for a while. But I know that some kids, even though what we're going to do today is fairly easy, right? Some kids need 2 days of this. And it's way more important to do 2 days of this than to do 4-7. So I'm probably going to do a day of this in class, and then tomorrow's a practice day, and I won't do 4-7. 4-7 is you change formulas, solve for a single variable. We're okay if we don't necessarily do that. All right. So here's your homework. Some of these are not done quickly. Some of them are done quickly. Some kids will take to this really quickly, and they will be able to do much of this in their heads. Some kids are just quick on picking up patterns. Other kids will never see the pattern. It's okay. For those of you that see the pattern, oh yeah, these can be done pretty darn quickly. For those of you that can't see the pattern, it's okay. Follow the procedures that I show you, you'll be all right. Like, what in the world are we doing today? Well, you can kind of see it in front of you. It's definitely not, if 10 is the hardest thing and 1 is the easiest, it's definitely not a 1 or a 10, right? It's close to being a 4 or a 5, but it's new. So you got to be taught it. Some of you will need 2 examples to catch on. Some of you will need 20. Right? All right, here we go. Here we go. So we're still multiplying polynomials. Now, before the last class we had, before we did a review on exponents, we multiplied a monomial times a polynomial. It just looked like a distributive property. Today, we're going to multiply a true polynomial times a second polynomial. So we're going to multiply 2 polynomials. Okay? I can't stress how important this is. This one is way up there, way up there. Okay? It's also pretty easy. All right? Today you're going to figure out whether you can pass or fail algebra 1. If you can listen, if you can do the procedures, and you can catch on in one class, you're going to pass algebra 1 if you devote that same attention every day. If you give me your full attention and this makes no sense and you're lost, you're going to fail algebra 1, okay? Because this is a basic level. I'm just going to submit to you, no one's going to not understand what we're doing today. Okay? It's just a new technique of procedure, right? Learn the procedure, write down the steps, right? And do all the examples. Until you get to the point where you can teach this to someone else, you don't know what you're doing. Eventually you'll get to where, oh, I can show someone else how to do this. That's how you know you got this, okay? I don't want to make this seem like it's a really, really complicated. It's not. It's pretty easy, but it's new, right? You haven't done it before. And it's way more complicated than, oh, wait, I just add the exponents. That's simple, right? It's more complicated than that. And I think we can all admit that this class definitely has a attention issue, like devoting your full attention to that.
To your slides?
I did. I made this specially for you guys. All right.
Yay.
This was not something I typically show. But I know, because I've taught you guys, for some of you, for 3 years. I mean, I know that you can do this stuff. All right, we've done this one, right? This is kind of where we left off. We have a monomial times a binomial, right? Monomial times a binomial is just a distributive property, right? So monomial times a binomial, easy, distributive property, okay? So let's see, the first arrow, 2 times 1 is 2, x times x is x to the second power. We add the exponents. 2x times 4 is 8x, and we're done, okay? Today we're going to be doing a binomial times a, eventually we'll get to a binomial times a trinomial, okay? But for today, we'll concentrate on a binomial times another binomial. Okay, so that's what we're doing. And the question is, well, how would this even work? Like, you don't have a frame of reference for how this would work. Turns out there are lots of methods, right? I can think of 4 main methods. Our book would like me to teach you 4 methods to get to one answer. I learned a long time ago that why in the world would I teach you 4 different methods to do it? So what I did over my years of teaching this is simply at the end ask the students, which method do you like? Universally, over the many years, kids were like, say, well, this is the method that we like. So that's the method that I teach you. However, of the 4 methods, one of them was almost always taught. That's the way I learned it, right? It's an acronym. It's got a word. And when your parents or your older brothers and sisters look at what you're doing, they're like, oh, you're doing it, and they'll say this word. So I always also teach a second method, because I'll have kids who'll come up to me and say, oh, my mom took the paper away from me. She said, why don't you know how to do this? And it's the word that I'll describe here in a second. And so then I said, okay, well, then I'll teach them that method too, just so that they can have a frame of reference for what your parents mean when they see this. Okay, so the methods are, this is what your parents will say to you. Hey, look, you're foiling, right? It's an acronym, right? They'll say, hey, you're foiling it, right? I'm going to teach you the distributive property. Most kids like this, and it makes sense to them. There's also 2 other techniques. One's called the vertical method. Works great when you're multiplying, I don't know, binomial times a quadrinomial or trinomial. I will show you this, just not today. And there's one other method that we're not even going to mention. The book uses, it's called table method. You make a table. I can get no kid to do this with a table. All right. So of those methods, today I'm going to show you these two and then talk about FOIL. All right. So let's talk about the one, and this is what we'll spend the most time on. And this is like a 5-minute class, really, to teach you how to do this, but we'll do lots of examples so that you become comfortable. So multiplying a binomial times a binomial. We've had the distributive property before, remember? That's when you have a number outside of parentheses, you just distribute it to everything on the inside. So we use this arrow method thing, so we need 2 arrows. 2 times x is, and 2 times positive 4 is, so not 8x, just 8. So we get 2x plus 8. So this is the mechanics of the distributive property. Well, unfortunately, we're not multiplying a monomial times a binomial. We're multiplying a binomial times a binomial. It ends up being as simple as you might think. We're not going to do the distributive property once. We're going to do it twice. Okay? So you're not going to have 2 arrows. You're going to have 4 arrows, right? So here's how it works. Imagine if it was that. Oh, by the way, it is that. But it's x plus 3. So we imagine there's the 3 there. We do the normal distributive property. 3 times x is 3x. Okay? And 3 times 4 is 12. Okay? Then we distribute the other thing, and the book doesn't show this, but I always put my arrows underneath. So the 2 arrows that go above is for this number, the 2 arrows that go below is for that number. But I'm still distributing this x to everything on the inside. It's just double distributive properties. X times x, x to the second power, x squared, and x times 4. You take all of those, see what you can group together, and you write your final answer. The book calls this the horizontal method. It's the distributive property. So I don't call it the horizontal method. I just call it the distributive property. So the calculations, once again, here's how it's done. Using the distributive property or the horizontal method. You take you can do the x first if you'd like, but I always do the 3 first. We take that. Now just be careful. It could be positive or negative. 3 times x is 3x. See what it did? Mm-hmm. Second arrow, 3 times 4 is 12. Positive 12, right? Then we do the second thing, the x right here. X times x is, and x times 4 is 4x. So is there anything here we could group together? 4x and 3x. You can see that we could group the 3x and the 4x. So we could write these from the highest to lowest power. The highest power is x to the second power. Scratch it off.
Is that the entire class?
Yes. Yeah. 3x and 4x is? 4x squared. We're adding now. Oh, because we're not 7x squared, just it's just 7x, and it's positive. Cross those out, and you're left with 12. Now, do I recommend doing this much notation? I'm going to say by the 20 of these, you won't be doing that. You'll just be writing down the answer. Some of you will be noticing patterns. Hey, I always know these are the 2 that I grouped together. But for many of us, we got to do a bunch of these before we recognize those patterns. Are you guys cold yet? Yes. Okay. You can play. All right. One more time. I always do this number first. I look to see if it's positive or negative. It's positive. Okay, so it's a positive 4 times 3x, which is 12x. Second arrow, that's a positive 4 times negative 7, which is negative something, right? Yes? We're done with that one. Now we go to the 2x. I put the arrows underneath. 2x times 3x is, okay. And then the last arrow, 2x times negative 7 is negative something. Hopefully you understand the negative something. Okay. Most people, when they do this method, immediately come to the realization that this one, the first, the last, are the ones that are always grouped together. Okay? We write it in decreasing. This is called standard form. We write it in decreasing order. What's the highest power here? 6x to the second power. So we write 6x squared. We group together the first and the last term because they're like terms. You got to be careful, though. 12x minus 14x is. See why you got to be careful? If you're going to make a mistake, it's usually this grouping here. Well, cross those out, and you're simply left with, and you're done. Hey, it turns out that this isn't a rule, but a binomial times a binomial turned into a trinomial. two linear binomials multiplied together turns into a quadratic trinomial. We will be spending the rest of the year on these two yellow parts right here. Next chapter is about, instead of going from this to this, the next chapter is about this to that. Next chapter is the hardest one. Next chapter, we will be taking the bottom and turning it into the top. It's called factoring. But not for today. Today's the easy class. All right, box number 1, 2, 2. What did we put in box 1?
Nothing.
I didn't have a box 1?
It was an equation.
I don't even remember there was a box 1. Okay, box 2. Here we go. If there's a problem, it's going to be when this number is negative, and you will forget that it's negative. I'm distributing -6. Julie, tell me what two numbers I'm multiplying there. That ain't a 6. That ain't a 6. It's not a 6. See what I mean? Saw how easy it is to make that mistake? She literally was sending laser beams to me. Right? She said, what do you mean it's not a 6? What are you, an idiot? It looks like a 6 to me. Right? You see how easy that is for your brain to focus on or drop a negative? It happens all the time. So it's a -6 times, which is, can you do that one? Okay. Then it's a -6 times, which gives us
18.
Okay. Then I do the second set of arrows. X times 4x is,
X 4x is 4x.
and then x times a +3 is. It turns out, and it's not always the first and last, but for these, a linear binomial times a linear binomial will always be like this. It turns out that the first and the last are the ones that you group together. But we will write them in descending order for powers. So the highest power is 4x squared, right? -24 and a +3.
-21.
Okay, and you don't forget your x.
X.
Cross out, cross out. Most people don't do the actual crossing out, but I'm just showing you that. And then left with,
-18.
-18.
you just multiply the binomial times the binomial. A linear because it's first power, linear binomial times another linear binomial, we get a quadratic trinomial. Why am I saying those words over and over again? You're going to forget. We're going to get to the test day, and you're going to forget those names that I asked you to write the table down that we had on our quiz that some of you got crazy wrong because you didn't have your cheat sheet or your resource card with you. All right. Box number 3. Do it by yourself or get started. I made a really hard one right here just to test you out. All right. Where's your pencil?
Because my pencil
Wait. Is your deal from the Tristan, you have an issue with pencils.
pencils just don't.
All right, let's see. -1 times x is -x. -1 times +4 is -4. X times x is x squared, and x times 4 is 4x. So combining all those together, I get x squared. +4x minus 1x will be 3x. And -1 times +4, -4. Cool? Porter, you. Okay, you understand the process? What? First arrow goes from what to what? What does that give us? Second arrow?
4.
Third arrow?
X.
X squared. X times x. Right? X times x, we add. Right? So 1 plus 1 is 2. And then the last arrow?
4x.
That's a positive x times 4. 4x. Yeah? Which can we group together?
So it'd be
So 4x minus 1x is 4x minus 1x is x. So it's x squared plus 3x minus 4. Yes? Okay. Second one, let's see, that gives me a positive 2x, that gives me a -3, That gives me, be careful, a negative 6x squared and a positive 9x.
Ooh, okay, I got the negatives.
So we got a positive 9x and a positive 2x. That gives me
Negative.
positive 11x. Okay? So we get negative 6x squared plus 11x minus 3. Yes?
So what if, like, say it was 1b times 2x? How would you do?
Yeah, we'll talk about that. She's saying what happens if the variables are different, okay? Turns into something slightly different. Things don't group together as nicely. I got those as coming towards the end here.
So you wouldn't.
All right. So for those of you that know what you're doing and just confirmed it because you got both of these right, do the next box. For those of you that are like, I still need some help, let's do box 4 together. Here we go, box 4 together. Aiden, tell me what to do. That gives me 12x. First arrow. Sorry. Second arrow. Tell me what two things the arrows touch right now. That ain't a 3. 6 times negative 3 is negative 18. Okay, next arrow. 1x times 2x gives you what? 2x to the second power. And then the last arrow? Don't attach an x to that. So negative 3 times x gives me, how about negative 3?
Negative 3x to the second.
Only time you get to the second is when it's x to the first times x to the first. Notice on this one, it's an x times a negative 3. So negative 3 times x, negative 3x. Of the 4, which ones can we group together? Which ones are alike? 12x is to the first power, 2x to the second power, not like terms. X is to what power? First power. Remember, if it's nothing, it means to the first. Are there any other here that are to the first power? So those are the two we can group together. So it literally says 12x minus 3x. 12x minus 3x is?
Yes.
Perfect. And then we simply write the rest in decreasing order. Now, I didn't do all the work. I just wrote the answer. But we got a 2x squared. 12x minus 3x is positive 9x, and minus 18 has no friends. Sorry, negative 18. The constant term never has friends. All right, I just you got to be brave. You got to admit in front of everyone who's like totally, completely lost. Okay, Julie, thank you. Distributive property, right? Where does the first arrow go? From what to what? Okay, what do you get? Perfect, you got this. Negative 8x. Second arrow. I'm going to put a plus 4 because it's positive. So we're done with the 4. Now we go to the other number here. What's this other number? Yeah, good. So it's that times that. It is. So negative 2 times negative 2. Not add, multiply. Negative 2 times negative 2. Negative times a negative is a, so positive 4x to the x times x, second power. Last arrow. Which ones can we group together? It's a negative 2 and a negative 8. Minus 8 minus 2 gives you, okay, we're not dividing. Same or different signs. These arrows being multiplied. This down here, we're adding, subtracting. Same signs means add or subtract. Hey, guys. So add the two numbers. but you were adding negatives, so, okay. And then we just write them in decreasing order. So we got 4x squared. You said that turns into minus 10x, and then plus 4 has no friends. You're not lost, Julie. So we'll take a break right there and just ask where, Rowan, where the problem's going to occur. Like, why are students going to get this wrong?
Because they drop it.
You're going to drop a negative. What else? That could happen, literally. So I guess in general terms, are you guys listening?
Don't understand.
The mistakes are going to be just your standard multiplication division errors. Like you divide 8 by 2 and for some reason you write 6. I'm not sure why, but you write 6. You're trying to divide and your brain stops working. You're going to have mistakes when you're dealing with positive and negatives. And then the big one, usually where the mistake occurs, is the adding and subtracting. If you still need those rules on your paper in front of you, same or different signs, add or subtract, big minus small, more positives, more negatives, make sure they're in front of you. And just realize that addition and subtraction rules are not the same as multiplication and division rules. 2 different sets of rules. She's the only one that admitted she was lost, and she wasn't lost. She told me the correct procedure perfectly, right? You're at the point where you're either confident you make a mistake, or clueless. We've just eliminated clueless. We got some people here confident they're going to make a mistake. So how do we move from confident you're making a mistake to confident? It's just practice. For those of you that literally have gotten everyone right that I just did, well, you're in that small section of kids that get it after 2 examples, right? Consider yourself lucky, right? For the rest of us, right, there's some times when I was in that category, but not all the times. For the rest of us, practice is what makes us keeps us from making those mistakes. So we're gonna practice. Okay. All right. I told you I was going to show you a couple other methods. So for all of you at this point, this is where it can become a little bit confusing. Like I'm going to show you another method, even though the other one worked fine.
When are we going to do different variables?
I'll just say this. This vertical method changed my world in senior year high school when I showed this. Because the distributive method is great, except when you multiply like a binomial times a quadrinomial or a trinomial. Turns out that most of us already use this method. If I told you to multiply 52 times 41, what would you do? Like literally, what would you do? Don't tell me to pull up a calculator. Rowan's saying, with his hands, he's saying, put 52 on the top, put 41 on the bottom, and you use your multiplication algorithm. 1 times 2, so forth and so on. This is the vertical method. And we can do the same thing with binomials. If you like this, and you think that this will cause you to make fewer mistakes, use this. I don't, when I multiply a binomial times a binomial, use the vertical method, but I use it when I multiply a binomial times anything larger, trinomial, quadrinomial. I think this makes more sense, and I make fewer mistakes. So all we do is we stack the 2, right? It's the same as this. I'm going to take the first thing, put it on top, take the second thing, put it on the bottom, and just follow the mechanics of that process. 3 times 4, so forth and so on. Okay? It's this process applied to binomials. So this is the vertical, and this is in the book, by the way. So we take the first one, we put on top, and the second one, put on the bottom, we multiply. You ready? 1 times 3.
3.
Where do we put that 3?
3.
Right here, as you normally would. 1 times x.
X. Just a second.
Okay. If you were multiplying 42 times 37, what would you do when you went to the second row? You add a 0 and you move across. I'm going to just move across to add a 0.
I don't like
X times 3?
3x.
You would go here because there's a 0 right here, right? X times x?
X squared.
And then you draw that line and you add 3 plus 0.
3.
X plus 3x, it's the same thing. Some people look at this and are like, wow, that makes more sense to me,
I
right?
don't like that one.
Other people look at the distributive property like, that's good enough for me. So I'm not going to say you have to use the vertical method. You're going to see me not necessarily, we don't many times in Algebra 1, we're not all we're doing is binomial times binomial. We get to Algebra 2, a lot of times we're multiplying larger things. I will always use the vertical method. One more time, just to try to show it to you. We stack the 2, and then we just do the multiplication algorithm. 4 times -1. 4 times 2x. Bring down a 0, move over 1. 3x times negative 1. 3x times 2x. 6x squared, and we draw that line, we add. Negative 4 and 0 is still negative 4. 8 minus 3 is 5x. 6x squared has no friends, and you're done. That's the vertical method. All right, to further confuse you, I am going to show you the FOIL method because that's what your parents and your older brothers and sisters are going to want you to do. Vertical method one last time. Hey, we're multiplying a binomial times a. If you use the distributive property, you get that much stuff written left to right. So for this one, for me, I think the vertical method works easiest. This times this, this times this, this times this, bring down a 0, this times that, this times that, this times that. You see how nice and neat that is? For me, I use the vertical method when I do anything larger than a binomial times a binomial. Yeah. This is called the Mr. C method. It doesn't like have a name other than vertical, horizontal. This was what my Miss Shanklin, she taught me geometry and algebra 2. And she taught me this method, and I was like, why did you show me this in algebra 1? She wasn't my algebra 1 teacher, but I was like, why didn't we learn this in algebra 1? Because this, to me, made more sense. Okay, last one, because this is what, I don't know, when you learned this in high school, were you taught the FOIL method, or were you taught the distributive property? Do you remember?
I remember the distributive.
Okay.
I was probably taught the FOIL method, but I remember.
The FOIL method is because people will come up to you and they'll say, hey, FOIL that out. And you're like, why are they saying this word FOIL? The FOIL method is the distributive property with words attached to it. Okay, so here's what it means, FOIL. F stands for first, O stands for outer, I stands for inner, and L stands for last. It's the distributive property. FOIL means first. Multiply the first two numbers together, first two terms. 2x times x is 2x squared. Outer is the outer things together. Well, that would be 2x times positive 4. I is for your inner, and L is for last. Our book uses this as well, too. It's not necessary. By the way, this is the distributive property, just in a different order. Okay? So if you hear your parents or whatever say FOIL, that's what they mean. So to use the first, outer, inner, last, let's see. 2x times x would be that. The outer would be 2x times positive 4. The inner would be negative 3 times x. And the last would be a negative 3 times positive 4. This is how I was taught in high school. There's nothing wrong with this method, right? But the distributive property requires less thinking about what something means. You still get to the same answers. The one nice thing about the FOIL method is it puts the two terms that you need to group together next to each other. See how it says 8x minus 3x? Maybe that's a plus to it, right? Using the distributive property, the terms that are grouped together on the outsides, but I find that as a minor point. We get 2x squared, 8x minus 3x is 5x minus 12. Okay, enough of that. How many people are not confident enough to do one all by themselves using any one of the methods that I showed you? All right, so here's what we're going to do. We're going to get started on homework. We've got 15 minutes. We're going to do this today. And then because this is so important, you guys don't realize how big and important this one is. Because it's so important, we're going to have a practice day tomorrow as well. Okay? All right, I'll be walking around helping you out, right? If you want to check your work, I can call out answers as well too, but we got to make sure we're working. Yes, Julie. I'll do a couple with you to help you out. What's up?
You didn't teach the two variables.
Oh,
Two different variables.
so we better do one last one so we make Josie happy. Let me see.
It's not a homework.
I know. Let me get to it. All right, special case ones. Everybody look at the board. So this is what Josie's talking about. First off, she's talking about what happens if the binomial is quadratic and the other binomial is linear. So which method do we want to use?
Then the distribute
Distributive. Okay. So 1 times x.
1x,
Okay. 1 times 3
3,
plus 3. X squared times x. Be
x to
careful.
the third power.
Oh God, no. It's not 2x to the third power.
X cubed.
It's just x to the third power. And x squared times 3.
3x squared. Yeah, 3x.
Okay, now as you look at this, what can be grouped together?
Nothing.
Okay. How many things have x to the first power? 1. How many things have x to the second power?
1,
How many things have x to the third power?
1.
There's nothing to group. So that's the, I'm getting there. There's more than one special case. So this one just literally turns into nothing groups together. Okay? Josie said this. Give me 2 binomials, Josie. Don't give me the one from homework. 3a plus c and
4c,
how about 4a?
4a plus 2c.
2c, okay. All right. First one gives me,
I don't know. 4ac,
okay, 4ac. The second one gives me,
2c squared.
good job, Tristan.
No,
All
boss,
right.
that's it.
That one,
12a squared,
and the last.
6ac,
Okay. How many ACs do we have to the first power?
2,
So that one and that one can be grouped.
10a.
How many c squareds do we have?
2.
How many other c squares?
Oh, it's none.
How many a squareds?
None.
So those can't be grouped. So we write them in decreasing order, and then if they have the same power, we go alphabetical. So we get what? 12a squared. These two can be grouped together. That gives me.
Huh?
That would give me
10 AC.
10 AC. So positive 10 AC, and then the last one plus 2c squared. You're like, wait a minute. You said write them in decreasing order. Yeah, we have an exception here. Now, I would not mark it wrong even if you didn't write it in decreasing order. I would mark it wrong if you didn't group like terms. Generally speaking, the first term and the last term of the trinomial, if they're two same powers, we write them separated just to keep them apart from each other. Right? All right. Hey, there should be papers out. You should be doing your homework. Right? Homework. And then I should be walking and helping people or confirming.
Why are no things for? Algebra is the best here.
Oh, I know.
Algebra is the best
Get your book out, get working, Rylan. Get your stuff out, get working.
Is biology.
All right, e-learners, Kaylee, any questions?
Not that I have right now.
Cool. Give it a shot. We're going to do another practice day tomorrow. I'm going to change that assignment 4.7 to a day of practice for today.
Okay.
All right. Catch you tomorrow.
Yep.